Okay, well hopefully when I plug this thing in it'll work, but we are continuing to solve trigonomic equations today. I know how much fun they are. They are tricky. So, we need to remember that we need to find the repeated answers. We'll have our calculators handy. There's my calculator. I was just about to say, I don't even have my calculator. I lied, I do. We'll do, even though your book does everything in radian, we'll go ahead and use degrees because that'll help us out to understand what is going on. So, solving trig equations, and we'll rehash two simple examples from yesterday, or Friday, I mean. So let's say I have sine. Well, let's do this. 3 sine x equals 5. Okay, and I want to. We'll make it not 5, not 5, not 5. That won't work. 2. We'll make it -2. Yep. Left in the loop in there. Okay, so here, right in front of me. Clear thing. There you go. Okay, so to solve this, what we're going to do is we're first going to divide by 3. So we get sine x equals -2/3. And then whenever we're looking for an angle, we do an inverse. So we're going to do x equals inverse sine of -2/3. And actually, you don't even have to put the negative in there. You can just leave it as 2/3. That doesn't matter so much. It will matter when we're getting the repeat answers. But just for the sake of argument, I'm going to leave it in. So when I do so I left it in, but whether you do or not, doesn't matter. This is going to get us a reference angle. So my calculator spits out -41.81. And just for ease of discussion for today, you'll have to read the directions for your homework. But for our notes, I'm just going to round to the nearest whole degree. So I'm going to say that x is about 42 degrees, -42 degrees. Now, when we're doing this, we're generally finding the answers 0 to 360. Okay? Those are the answers we want. We see that when we get the -42, that's neither of them. All right? Now, I'm going to go ahead and draw a unit circle here to help us find any other answers there might be. So hopefully my computer doesn't have a conniption. Okay? And I'll erase this. Okay, so what I'm asking, now in order to figure this out, I'm going to look, once I get to a step that looks like this, what I'm going to ask is, where is sine negative, right? And from our notes from before, we said sines and cosines has to do with x values on our unit circle, sines have to do with y values on our unit circle, and tangent is going to be this ratio, so y divided by x. Okay, so on this unit circle, cosine is positive, sine is positive, tangent is positive. And right here, cosine is negative, sine is positive, tangent is negative. And right here, cosine is negative, sine is negative, but tangent is positive. And then in our fourth quadrant, so quadrant 1, 2, 3, 4, cosine was positive, sine was negative, and tangent then was negative. I'm actually going to erase all that because it should already be in our notes. So we're just going to use this. Where is my thing? Okay. My computer's not being kind to me. Alright, so I'm going to erase all that. And now what we're going to do is we're going to go ahead and draw this out. So we said sine was negative in quadrant 3 and quadrant 4. Okay, so these are my two answers. So I'm looking for this angle right here and this angle going all the way around. And 42 degrees is going to be my reference angle. So, they're having way too much fun over there. So, this angle that I'm coloring in right here, that's our 42 degrees. So to get one of the angles, I'm going to do 360 minus the 42. And get 318 degrees. So that's one of my answers. And then my reference angle, I'm coloring in right here. That would be my reference angle right there, that 42 degrees. So to get the other answer, I'm going to do 180 plus the 42. And this is going to be different in each circumstance. So a way that you can check that you're doing it right, I showed you last week on your calculator. On y1, you would put in the negative 2/3. And in y2, you would put in the sign x. And we'd make sure that we'd have the view window, x min, as being, gosh, my thing. I need a new computer. I think that's something I'm going to purchase this summer. Y min is 0, or maybe negative 30, something like that. X max will be 360, or maybe 370, something like that, so that we get some room. Y min, we want to just make sure that we're, negative 3, maybe the max is 3. But we did that last week, so I don't want to do too much on that. So you can graph it and check your answers that way. All right, let's do a tangent one. So let's say I have tan squared x plus, let's say 5 tan x plus 5 equals 0. Okay, so what we're going to do with this is factor and then solve. So we're going to factor. We're going to treat it like x squared plus 4x. Let's make that a minus 5. Sorry. Make this a minus 5. I meant it to be factorable. Minus 5 equals 0. Alright, so when I go to solve this, I would factor it by x plus 5, x minus 1 like that. And then x would be negative 5, and x would be 1. So I'm going to factor this similarly. They're having way too much fun over there. Plus 5 and minus 1. Same idea, right? And then I'm going to say, well then tan x plus 5 equals 0. Or tan x plus 1 equals 0. And then I say, well tan x equals negative 5. Or tan x equals negative 1. And if I inverse tan both of those, so I'm going to have lots of answers here. When I do this one, when I inverse tan, I get x is about 79 degrees negative. Oops. And over here, when I inverse tan that, I get negative 45 degrees. Now again, we're solving 0 to 360. So we've got to keep that range in mind as we're doing these. So I think, well, where is tangent? Oh gosh, I didn't mean to erase that. So I'm thinking, at this step, I'm thinking, where is tan negative? Right? Well, tan is negative in quadrants 2 and 4, right? And 79 is going to be my reference angle. So 79 is this angle right here and this angle right here. Remember, it's a reference angle is always made with the x-axis. So what I'm looking at here is I'm looking at to find this angle and this angle. So to get one of them, I'm going to do, well, my computer computer's having a hard time again. I'm going to do 360 minus the 79. That'll give me quadrant 4. And for quadrant 2, I'm going to do 180 minus the 79. And that 2 should not be there. That was because my code was being dumb again. So 360 minus the 79 gives me 281. And 180 minus the 79?
So what about the 45?
I'm getting there.
No,
Okay, is 101. Okay, so now the 45 degrees is going to be still the same 2 quadrants, right? So 360 minus the 45. Oh, sure, now you work nice, computer, for once in your life. And 180 minus the 45. Okay, so I do both of those. So I get 315 and 135. So I have 4 answers in this case, right? Now we can verify on our graphing calculator. Okay? Now there's a few different ways that we could do it. We could go all the way back to the beginning, and I could put this into y1, and I could put 0 into y2, and I'm looking for where they intersect. And then that should verify all 4 of my answers. Okay? G-solve, intersect, right? And you can even do that right at the beginning so you know what you're working towards. Alright, that got really sloppy. So again, we're solving 0 to 360. I'm just going to do a couple more that are maybe tricky. Let's say I have cosine of theta equals sine of theta cosine of theta. Well, now I have a bunch of stuff, right? Our key, like with quadratics, so write this down, like with quadratics. Get to one side and factor. Okay, so we're going to get everything to one side and factor. With trigonometry, this next thing I'm going to write, very, 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 very important. Never, ever divide by a trig function. I can use division. Like I could divide a 2 or a 4 or something like that. I'm not going to want to divide a trig function because when I do, now it's mathematically okay. It is mathematically okay to divide both sides. If I wanted to divide both sides by cosine, that's mathematically, algebraically okay. But as far as trigonometry is concerned, when I divide out that cosine, if I were to divide both sides by cosine, if I were to do this, even though algebraically in algebra class you would say, yeah, that's okay because you did the same thing to both sides, you get 1 equals sine. And then we would get some answers, and those answers would be okay. But the problem with this is by doing that, what I've done, oops, I did not mean to click that. What I've done is I've actually inadvertently canceled out other answers. So I won't get all of them. So you need to follow this in order to preserve all the answers. So that's why we're going to do this thing. Like with quadratics, we're going to get, even if it's not a quadratic, we're going to get to one side and factor. Okay, so this is not a quadratic. So we get everything to one side. So I'll write 0 equals, I'm going to subtract that cosine. So it equals sine, now whether it's a theta or an x doesn't matter. Sine of theta, cosine of theta. I don't know what my computer does, like every 2 minutes that it decides, I don't know how to write. I'm going to erase this, give myself some room here. So we cannot divide, so we subtract out that cosine. So we subtracted cosine from both sides. We are not going to divide it. That was cosine
Wait,
theta.
why do you have 1 minus sine theta?
I was showing you what not to do. So don't do that. You don't even need that. So now we're going to factor. We can factor out a cosine. When I do, I get sine of theta minus 1. So that is one of the answers, so that you would recognize that from before. Now I split that. Cosine of theta equals 0, or sine of theta minus 1 equals 0. And then I would say, well, theta equals, the inverse cosine of 0 is actually 0. Wait, no it's not. It's 90. It's also 270. I'm going to jump to that, because cosine is 0 at 90 and 270. Here I'm going to do a step to solve. I'm going to add that 1. I'll inverse sine, and I get theta equals 90 only. So you can see, if we had divided by cosine, we would have lost the answer of 270. So both of these answers. Now, I also have this 90 again, but I don't need to list it separately. Okay, I'm going to do a bunch of odd numbered problems that are in your textbook. So this is going to be page 917, and then we are going to be done with notes. So page 917, let's say I have 2 sine of x plus cosine of x minus 1 equals 0. Now this is a challenging problem, and I cannot give you like every combination of problem that you'd have, or I can just give you little hints about what you might want to do in certain situations. So I notice I can't factor. Why can't I factor? Like, I can't factor because this is like having x squared plus y. Yeah, so like these are different, right? When we factored before, we had 2 sine squared x plus sine x minus 1 equals 0. If we had this, we could factor it. Well, we could try at least, okay? Because then it'd be like having the same variable. So when this happens, I need it all to be the same trig function. Now, last slide, like if I go back to there, I had cosine and sine, and I didn't change them because I didn't need to factor. I was able to factor okay without changing them. So I was able to factor out this cosine all right without doing anything. But what I'm talking about here is if I can't factor it the way it is, then I need to get it all to be the same trig function. So I'm going to change this one. I'm going to use the Pythagorean identities to go ahead and change that one. So remember, sine squared x plus cosine squared x equals 1. That means sine squared x equals 1 minus cosine squared x. And you see why we proved those identities earlier. So we're going to take that and replace it in here. So we're going to say 2 times 1 minus cosine squared x plus cosine x minus 1. And we're just going to go through some simplifying here. Now, I always like my highest power to be positive, so I'm going to move everything to the right. So I'll have 0 equals 2 cosine squared x minus cosine x. And then that 2 minus 1 is 1, and then I'll subtract it. Okay, so I have that. And now I'm going to factor it. So all I did was replace the sine squared with the Pythagorean identity. I distributed. And then I moved everything to the right, so I have a positive 2 cosine squared. That's going to make it easier to factor. You don't have to do that, but I find it's easier to factor when we do. Now we're going to go ahead and factor this. So I get minus 1 right here and plus 1. And then we say 2 cosine x plus 1 equals 0. Cosine x equals Negative 1/2.
So wait, is that one supposed to be negative if you got it over?
Did I make a mistake factoring?
Well, isn't it supposed to be positive 1 once you get it over?
Well, don't forget this 2 right here. 2 minus 1 is 1. So I did that all in one step. All right, anyways, inverse cosine of negative 1/2, I get 120 degrees. Now that's not the reference angle. The reference angle will be 60. We'll draw that out shortly to see. This one, cosine x minus 1 equals 0. Cosine x equals 1, which means x equals 0 degrees if I inverse cosine that. Or 360. So that one's easy to get the extra answer. So this one we'll go ahead and work on the extra answer. I'm going to erase the top. So I erase this little bit right here. I'll erase that little bit as well. Okay, and just kind of nice and okay. So here's my unit circle. I'm thinking, where's cosine negative? Well, cosine is negative in quadrants 2 and 3. And the angle that I'm looking for is this one and this one. Okay? Now 120 is not a reference angle. How do I know? Because it's not acute. The acute angle would be in here, and that would be 60 degrees. So I already have one of the answers, the 120. My reference angle is 60, which means the other answer, which is down here, okay, that's going to be 180 plus the 60. So that's going to be 240 degrees. So my other answer is 240 degrees. Now, if you're checking your answers in the back of your book, they will have them in radians. So if you want to check your answers that way, you'll have to convert them. I do want you to do these in degrees, even if it says not to. Do it in degrees. It'll be easier for us. This is the first time us doing things this complicated to understand it. So we'll stay in degree mode. Okay, so I have 4 answers. All right, let's go on. All right, so this one ends up being trickier than we would think. I'm going to divide both sides by 2. And then since I have it squared, I'm going to square root it. So tan x equals whatever the square root of 5 divided by 2 is. And tan x equals, this is going to be the tricky part, the negative. So this is important. When we, and we should have talked about this earlier in the year, but when we root, as part of solving, there's 2 answers. A positive one and a negative one. So we need to do both of them. So we're going to inverse tan the square root of 5 divided by 2. And that'll give us one of our situations. So I'm going to, again, round this. So my calculator spits out about 58 degrees. And then when we do the negative one, we get negative 58 degrees after rounding. So now I think, well, where's tangent positive? Tangent is positive in quadrants 1 and quadrant 3. So 58 is my reference angle. So if I look at quadrants 1 and 3, I have this situation. So I want this angle and this angle. So to get the other one, I'm going to do 180 plus 58. And get 238 degrees. So here's 2 of my answers. And then tangent is negative in quadrants 2 and in quadrant 4. So positive 58 is actually my reference angle. So I'm going to do 360 minus 58 to get the quadrant 4 answer. to get the quadrant 2 answer, 180 minus the 58. Because I take a look, 58 is going to be my reference angle, which is right here, right here. It's always, reference angles are always positive. So if you're wondering why did I ignore the negative, that is why. Reference angles are always positive. So 180 minus the 58 is 122 degrees. So for your homework, I think I'm okay if you round to the nearest whole degree, just so we're making our work a little less complicated. It's complicated enough, isn't it? I think we get 302 here. So 302. So these are all our answers for this case. Definition. X-intercepts occur when y equals 0. So I'm not going to do any problems with that, but it is in the directions. It gives you a trig equation. It says find the x-intercepts. Well, then just replace y with 0. We've done that before, so I don't see need to talk about it again. I want to get to these 2 or 3 really, really tricky ones. Okay, so here's what we have. 2 sine theta plus 1 equals cosecant. Now, our calculator does not have on it inverses for cosecants, cotangents, and secants, right? So whenever we have cosecant, secant, and cotangent, switch to the reciprocal. Use the reciprocal identity. So I'm going to rewrite cosecant as what? Yep, 1 over sine, right?
Oh, I thought you said you use the reciprocal.
Well, right. It's called the reciprocal identity. Okay, so cosecant equals 1 over sine. Now, from algebra, whenever we have fractions, what do? We're going to clear it. Now, so this is just remember I said we can never divide by a trig function because we lose answers. But it's okay to multiply. That is fine. So we get sine squared theta plus sine theta equals 1. And that's all right. And then I can factor out a sine, so I will. Don't write that, I'm dumb. Don't write that. Bad, Kane. Bad. Why is this bad? This must be a 0. Okay? So I just almost made an algebra 1 mistake. So we're going to subtract that 1 first. So we have 2 sine squared theta plus sine theta minus 1. Now we factor. So we have plus 1 right here, minus 1 right here. So sine equals 1/2, and sine equals -1. We'll inverse sine. I get theta is 30. And right here, that should pop out 270. It might give us -90, but that's the same thing. Yep, 270. Remember, add 360 repeatedly. If it gives you those negatives, that'll give you the right angle. So for the 1/2, and I'm not gonna bother with the. If I tried to do it with the -1. I'll get answers beyond 360, so I don't need those. So I'll just talk about the 30. Where else is sine positive? Well, sine is positive in quadrants 1 and 2. Okay? So I'm looking for this angle, and I already have it, and also this angle. So the way to get that angle would be 180 minus 30, which which is 150. I realized I'm using the reference angles fairly quickly. But you can verify easily. Now, if I wanted to check my answers here, and I think after I'm done with the video, we'll come back to this problem. So please jot it down. I want to show you this on the calculator. We'll just gather around my desk and I'll show you how we can check this. But this would be y1, and this would be y2. But the trick is, well, how am I going to write that in my calculator to get my intersections? And we do get a pretty cool graph when we graph that. All right, I'm going to do one more of the tricky ones, and then we'll say, yay, we are done with the trickies.
Why didn't you get a fourth one?
Because when I do this reference angle of 90, I actually don't get any more answers. I would get something like 360 plus 90, which is beyond the realm of my answers that I want to take a look at. All right, next tricky one. Now, remember, I said if we have two different trig functions, we do want to write it in like have one, but if I can avoid that, I'm going to. So I do see a fraction here. I'm going to clear that fraction. So that's the first thing I'm going to do. Clear that fraction. Always clear your fractions. And, I mean, I could subtract this cosine to the other side, right? So 2 sine theta cosine theta minus cosine theta. And actually, you'll get used to seeing this combination right here. That's actually a common combination. I can just factor out the cosine, right? And if I can avoid changing one to the other, I will. So I get cosine equals 0, and sine will equal a half. So I'll get here 90 degrees. Right here, I will get. Phone keeps going off on something's going on. 30 degrees. All right, so cosine is 0 in two places, 90 and 270. How do I get that 270? Well, 180 plus the 90. The sine is positive in two places, quadrant 1 and quadrant 2. So my other answer is 150, and I get that by 180 minus 30. So these are all my answers. All right, so our assignment is going to be page number 916. Now we already did up through 18. So what I want us to do is work on numbers 19 to 33 all. Okay, and then we'll take a look at the calculator problem that I wanted to do. So I'm going to stop this recording.